Operating System Concepts 10th edition. These are the slides that I'm using from that book, and the book is by Silverskaj, Galvin and Gagny. Okay, so most of the times whatever I'm teaching from wherever, I will typically give you a handout of a PDF or whatever the data, whatever paper that I have to give, I'll just give it to you through the Google Classroom. Okay, so just after the completion of this class, I'll also send this out to you guys. So all these slides that I'm using, that right now I'm presenting, all of them are based on this book. You can get it on the internet also, but mine is very abbreviated, so you might just want to take a look at these guys. So can you identify the various let's see components that are here? Say for example, what is this guy here, right here, this portion here in the photo, this portion. This portion is the CPU probably, and this here, the long one, this guy here, this here, right here. I'm talking about this I don't know, I'm not able to, this one, this lamba one, this guy is a CPU, no? So this portion is CPU. And what about this long thing here?
RAM.
Yeah, this DRAM, no? DRAM. Can you identify others? What about this guys? These guys here, this one, this one also. These are where you will put the hard drive probably. Okay, this is where you'll put the hard drive. What about this long one here, this guy, this big thing here? What are they? What is this? Here, this gun, this is for the GPU, no? General the graphical processing unit. GPU. This, the white ones, what are they? PCI. Okay, these are used for connecting peripherals, no, various peripherals. And then what? Then probably you have this here, this black, inside this black thing, what will there be? There will be probably some other chip, no? What is that chip? Here it's CPU, here it's RAM. And what is the thing that connects the CPU and the RAM? The thing that connects between the CPU and RAM is called the north bridge. So this guy here will probably be the north bridge. So now the IO also has to be connected to RAM, no? And here this hardware devices like this graphics card and this wireless or Ethernet card, etc., they connect to the RAM via another chip called the south bridge. So there are two chips, no, south bridge and north bridge. And on this on the left side, what do we have? We can see what? We can see that there is a here Ethernet. So this guy here will be the RJ45 connector. RJ45. Okay. RJ45 connector. What about this? The big thing here, that will again be some kind of serial or some other kind of connector, is it not? A VGA connector. So this guy here will be the VGA connector, vector graphics adapter for the graphics card, I think. So okay, and then so we have keyboard and mouse connectors here, then we have VGA, Ethernet connection, etc., and all of these are the connectors. This here is the main power socket. Here this the power that comes from SMPS. So we have a fair idea of this hardware, but in order to understand how this hardware works is very difficult. So if, say for example, you are writing, you want to write a video game, or if you are writing a database, or if you are building a website, you are really not concerned with all this hardware. There is a complexity to hardware, and there are hardware electronics engineers who are designing all this. But for us, for standard users who are doing software development or running some video game or doing a browser, all this hardware complexity is not important. We are really not interested. We don't even want to know how complex this hardware is. Okay, So this is the first thing. Modern hardware is very complex, and it is not, we are not necessarily interested in knowing about this modern hardware. That's not. So you can see that there are multiple applications. There are many applications sharing the same hardware. They are sharing the same hardware. Say for example, browser. Browser is using the CPU, is it not? The text editor also does the same thing. And if you are playing a video game or doing something using a calculator or whatever application you are doing, all of these applications are sharing the same hardware, meaning they are using the same CPU, they are using the same CPU, they are using the same main memory, and they are using the same storage system, they are using the same hard drive. So we have to have a fair share of all the hardware resources that we have between all these applications. Okay, so all these are applications that we are seeing now. So let's quickly see, let's quickly understand what we have just said. So we are seeing two distinct things. This portion, browser, software, text editor, this game, compiler, etc. All of these things that we are studying, all of these things that we use, all of them are actually software. Is it not? And on the other hand, we have all this CPU, main memory, hard drive, USB drive, etc. All of them are hardware. So what is the connection between this hardware and this software? We know that this connection is the operating system. This connection is the operating system. Okay. So hardware, we have already seen CPU, memory, IO devices, etc. will be there. Application programs, there will be video games, browsers, etc. and they are executed by the users. So what is the connection between this hardware, this guy hardware, and this software portion, this portion? Okay. The connection is the operating system. So the operating system concept books gives you this definition, describes this by saying that an operating system is nothing but a system software. It's a software that is used on the system, not one application but for the whole system, and it acts as an intermediary. Intermediary matlab in between. So it's okay, in between. So it is in between the user of a computer, meaning the software or the user, and the hardware. So these are some of the goals that are typically used when we design an operating system. So now let's take a look at this picture. We have already seen that there are these application programs, and remember, when we say application programs, all of them are running in software. Okay, and this portion, the computer hardware here. So we have just said that what is the intermediary, or what is in between this software and hardware? This software and this hardware, what's the intermediary? Operating system is the intermediary. Okay, operating system is the intermediary, and application programs are used by the user. So now we can clearly understand the role of operating system. What is an operating system? Is a system software program that lives between, or that exists between, hardware and software. Now, according to this Silver, Skaggs, and Galvin and Gagne, they say that, see, look at where OSs are present. OS are present in toasters, bread वगैरह बनाने वाला, ship के अंदर, spacecraft, it's there in the cars, it's there in the game machines, it's inside TVs, in the industrial control systems. Okay. Now all of them actually have some kind of OS, and it's very difficult to define what exactly is an OS. So rather than talking about what OS is, it's a good idea to talk about what OS does. Okay. So that's why they say that there is no universally accepted definition. There is nothing. And everything that a vendor ships is what could be an operating system. Okay, so there could be system software, there could be application program, there could be middleware like databases and gaming engines, etc. Databases and virtual machines. Okay, all these things are called, now they are called middleware. Okay, so what is an OS is very, there is no one universal definition of operating system. If somebody says what is an operating system, you can describe it. But the description is really not necessarily complete. So what they say is, rather than saying what operating system is, it is a good idea to say what operating system does. Okay, so that way also we can understand what an operating system is. So let's see what operating system really does. First, we have just seen that hardware is very complex, especially modern hardware is very complex. And one of the key things that we have to do is to hide the details. Okay, say for example, hide the details means what? Say for example, I have a file that I have, a video file or a movie file that I have copied into USB. after when I bring this USB thing into my laptop, okay, or into my mobile phone and store it in the SSD. SSD will be the storage device on the cell phone or a good quality laptop. Okay, if you copy this movie file from this USB to SSD or USB to this IDE hard drive in a laptop, it really doesn't matter, no, where this movie has gone. Whether it was in USB, you can play it. Whether it's in hard drive or a SSD drive, it really doesn't matter. So we can now clearly see that once we have this movie, whether you store in a USB external hard drive or an internal hard drive or an SSD or any type of hard drive, we can always go and play, and we really don't care where it is stored. That's what we mean when we say that operating system can hide details. And how does it do this? This idea is done by the abstraction called a file. We'll talk about this later. But what are the kinds of things that you can do with a file? We can read a file, you can write a file, you can open a file, you can edit the file, etc. So all these operations on something called a file is the contribution of an operating system. So operating system provides us the abstraction of a file. Okay, that's number one. Second example is, for example, you have a browser, you have internet browser or Firefox that connects to that is in communication with the internet. Now, whenever that connection happens, okay, it could be any kind of connection. It could be like file transfer, it could be watching movies or going to YouTube and doing whatever. Remember that we are really, as a user, we are really not interested on how this communication occurs. It could be a server far away in some foreign country, and the server could be running on Windows, it could be running on Linux, it could be running on something else, who knows. But our browser, Firefox or whatever, is easily able to connect to the internet any time. There is no problem. Now, how is this possible? It's done by a concept called a socket. Okay, so this we are going to study in the next class. We'll take a practical example of how to write a socket in C, using C language in a Linux operating system. Now, what does a socket provide? We'll later on see that socket provides two different operations, send and receive. The two examples of how hardware details can be hidden by the operating system. There are some others. Say, for example, if you have multiple applications, you are running on the same RAM. How does it do it? Again, it does some kind of resource management. And in this particular example, this memory is treated as a resource. The same thing happens with the processor. There is only one processor and there are multiple processes. And here, what is processor? Processor is a resource. So here memory is a resource, same memory shared by so many applications. Here processor is a resource shared by so many processors at the same time. Similarly, your desktop might be connected to a printer, and there are multiple computers, multiple jobs, all want to print to the same printer. If you permit all of them to print to the same printer at the same time, don't you think the printing will all come out jumbled? I write in English and I send it. Somebody writes in Hindi, somebody writes in Ohomia, and all of them go and print to the same printer at the same time. So the first line will be English, the next line will be Hindi, the third line will be Assamese. It's going to be a complete mess. So if you have only one resource, like a shared resource, like one printer, if all of them want to access, there has to be some kind of access control, no? Some kind of resource management. So that's another key aspect of an operating system. And another one that is not really obvious is this guy: isolation and protection. What do you mean by this? Say, for example, I have an application I am running on Firefox. Now, this Firefox needs access to RAM. Every application that we run require main memory access. Now, if I am running 5 different applications, and if they work off the same memory, then they are going to corrupt the memory, no? It's not going to work. Application A accessing the same memory, application B accessing the same memory. That's going to be a complete chaos. Therefore, it is important that different parts of the memory should be allocated to different processes. Some portion of the memory should be allocated to process A, another should be allocated to process B, etc., so that there is no interference. And that's how you will isolate application specific memory. So for each application, for each process, for each app that you are running, they should easily execute independently in different parts of the physical RAM. And that is the idea behind isolation and protection. So now we see that rather than saying what OS is, which is a very complex and not really accepted definition, it's a much better idea to say what does an OS do. So we see that OS is able to hide the hardware details, hardware complexity. It's able to do resource management, and it also provides isolation and protection services. So we clearly know whatever OS it is going to hide the hardware complexity. It's going to do proper resource management. It's able to protect and isolate applications. And how does it do it? It has direct access to actual hardware. It has direct access to actual hardware. So remember that in a real life, in modern day operating system, it's impossible, unless you are a kernel engineer, it's impossible for you to actually access the hardware. All accesses to the hardware will always pass through the operating system. Okay. Now you'll take a look at all these guys and figure out, okay, which of these applications, which of the things here could actually belong to the OS. So you can clearly see that file editor because you can uninstall an editor, you can install an editor. It's up to you. No, you can install Notepad, you can throw away Notepad, you can use some other editor. So definitely this is not a part of the operating system. Browser, you can either install Firefox, or you can install Chrome, or you can install Opera. It's up to you. So this is really not a part of operating system. Device driver is a part of the operating system. RAM cannot be because it's hardware. Very simple. This guy cannot be because this is hardware. Okay. Process scheduler, yes, this guy is a very important part of the operating system. Printer, of course, is hardware, so there is no question. Hardware cannot be part of a operating system. Okay, so we have just seen what are the basic components of a standard typical OS. And now let's see the various roles of an OS. Okay, so the first activity is that this multiple processes share the same RAM. Okay, if you have a random access memory, आपने एक RAM खरीदा 4 GB का, you put it in the computer, all processes will be able to share. No, they can use the RAM. This facility, can we call it abstraction, or can we call it arbitration? By the way, what's the meaning of abstraction? U-turn. Okay. But does this thing actually look like a U-turn? Does this arrow look like a road? This arrow, it doesn't look like a rod, no? But we have been trained in such a way that if we look at it, we know that this means no U-turn. So definitely this arrow here doesn't look like a road at all. It doesn't look like anything. But we have mentally abstracted it. We have created an abstraction. Okay. So this is an example of an abstraction. Abstraction is a simple model of something very complex. Okay. And simply, my pen I have left in the department. Oh, next time it will be better. Simplified. It is a simplified model. So what is abstraction? Abstraction is a simplified model. Arbitration means? Arbitration is if two people are trying to do something, both the persons want to ride the same bicycle. Then the father says no, first the elder one will ride and then the younger one will ride. Okay, that's an example of arbitration. So now you have understood what abstraction is. Abstraction is a simplified model of something. It's not the actual thing, it's just a simplified model. It's a simplified model. What is arbitration? Arbitration is whenever the two things or two or more people or something wants to access the same thing, they will say no, roll number 1 will do it first, then roll number 2 will do it, then roll number 3 will do it, etc. So you give an order when you try to access something. Okay, now based on these two definitions, can you think of what will happen? So now we see all these examples, OS examples. Microsoft Windows you already know. There are these Unix-like Windows. Mac OS, you already know. Mac OS is from Apple, is it not? It's one of the famous. It is one of the famous OSs. And what is Mac OS? Mac OS is also a form of Unix. It's also a form of Linux. You can call it a form of Unix actually. So Mac OS 10 is also an example of Unix. And Linux already you know. We are right now my machine is running on Linux. What about others? Handheld devices, cell phone. What is Android? What kind of operating system is Android? Android again is Linux, no? Is it not? Android is an example of embedded Linux operating system. Is this okay? Android, the thing that we are running on our cell phones, all of them are running on some version. It's called embedded Linux. Okay, it's now taken over by Google, but the fact is that it's also based on. And iOS again is from Apple. Okay, this is again from Apple. So Apple has given us two operating systems, one iOS and another Mac OS 10. And what about Symbian? Symbian you will not see. Our time we saw Symbian, like 10 years ago Symbian was there. This Symbian is also a phone operating system. Okay. Now there are so many computing environments. You can just go through this. I'll just give you this. Traditional you already know, running on desktop, laptop, etc. Mobile, though we have just seen handheld, smartphones, etc. Right now there are so many there. See, cellular data networks. Right now we can use IEEE 802.11 wireless. That's the wireless standard for Wi-Fi. And other cellular data networks means 4G, 5G data networks by Jio and others. Okay, I don't know much about this. Okay, and what are the mobile phone? What are the famous ones? Apple iOS and Google Android are the ones which are dominating these are the operating systems that dominate the mobile scenario. You also have what is called a client-server architecture. This is the experiment that we are going to do in the next class. Okay, we'll look at how this thing works. Peer-to-peer, if you are familiar with VoIP, voice over IP, Skype is an example of voice over IP. There are some others like Napster. This is old now. Gnutella. All these are examples of classic operating systems. Classic connections are what is called client-server architecture. What we are going to do in the next lab. But there are architectures which are based on what is called peer-to-peer. Okay, so all of these are clients. They are all connected to each other, and there is really no server. Okay, cloud computing is now a big thing. Okay, so everything that we have right now, even email services provided by Gmail. There is this Amazon has now, especially for AI and other things, they are providing all this virtualization facilities so that you can run millions of virtual machines. And there are these real-time embedded systems. And where are real-time embedded systems required? Real-time OS, where are they required? They are required where something is heavily time constrained. Say for example a medical situation where the moment you get some beep or some emergency situation, the OS has to respond immediately. It's an example of a real-time OS.